Hey everybody, welcome to Conceptual Geometry, Lesson 2.3, Angle Bisectors, Perpendicular Bisectors, Isosceles, and Equilateral Triangles. Let's start by talking about a perpendicular bisector. A perpendicular bisector divides a segment into two equal parts and forms 90-degree angles. So in the diagram at the right, it says CJ is the perpendicular bisector of DP. What would we know? Well, we know we're going to have two right angles there, and that DJ and JP would be equal. So DJ equals JP, and I'll make this a little bit easier, 1 and 2. Angle 1 equals angle 2 equals 90 degrees. All right, let's look at an example. It says CD is the perpendicular bisector of PQ. So before I go on and read any more, I'm just going to note that perpendicular bisector, those two are right angles, and this segment and that segment are going to be congruent. And it says if the measure of angle CDQ, so let's trace it, CDQ. Obviously that's going to be a right angle, right? That's 90 degrees. So this stuff here is going to equal 90 degrees. 3x plus 33 equals 90 degrees. And we'll go ahead and solve that. Subtract 33 from both sides. That gives me 3x equals 57. Let's divide by 3. And x equals 19. All right, so I found the value of x. Now it says PD is 2y plus 10 and PQ is 50. So PD, this is PD, and this is PQ. So obviously those two pieces are not going to be equal, so I have to figure out what the relationship is. PD is 2y plus 10. Let's fill that in. 2y plus 10. PQ is 50. Now what I have to do, because I marked this earlier in the figure, I noticed this and that are congruent. So PD is equal to DQ. Whatever we label PD as, we do the same over here for PQ. So let's do that right now. It's going to be 2y plus 10. And now I think it's easy to see that 2y plus 10 plus 2y plus 10 is going to equal the whole thing. And that's going to be my equation. 2y plus 10 plus 2y plus 10 equals 50. We'll combine like terms over here. That will give me 4y plus 20 equals 50. Subtract 20. 4y equals 30. Divide by 4. And yes, we can get decimals. That ends up being 7.5. All right, found x, found y. Ready to move on. The next definition is going to be an angle bisector. Well, kind of like a segment bisector divides a segment into two congruent parts, an angle bisector divides an angle into two equal angles. So over on the right, it says BD bisects angle ABE. So BD is this ray, bisects the angle, which means these two angles are going to be equal. Angle ABD equals angle DBE. Let's try an example that involves an angle bisector. BD bisects angle ABE. So exactly what we just talked about up above. First thing I'm going to do is mark those two angles equal. If the measure of angle ABE is 72, well, trace it. ABE is the whole angle. So the way I'm going to denote that is over on the outside of it, I'm going to put a big arc, and that's going to be 72 degrees. Then it says the measure of angle ABD is 3x plus 9. ABD, so that's this angle here, is 3x plus 9. Find the value of x. So there's a couple ways you can approach it. I'm hoping it's obvious that this angle right here is not equal to 72 degrees. It's actually going to be half of that. So what I want to do, there's a couple ways I can do it, is I need to find the measure of this angle, knowing that the whole thing is 72, or you could write 3x plus 9 here and do 3x plus 9 plus 3x plus 9 equals 72. This might be a little bit quicker. If I take 72 and divide it by 2, I'm going to get 36, which means both of these angles have to be 36. So it might be a little faster if I take 3x plus 9 and set it equal to 36. Subtract 9 from both sides. 3x equals 27. Divide by 3, and x equals 9. Now, if you had done 3x plus 9 plus 3x plus 9 equals 72, you're going to get the same exact answer. So either way is 100% correct. Wow, this one looks a little complicated. BD bisects angle ABE. So this is BD, and here's angle ABE. So we got to be careful here because I've got another angle that's involved. This angle here, ABD, is going to be equal to angle DBE. All right, so if I highlight them again, this angle here is equal to this angle here. You got to keep track of that. And then it says if the measure of angle ABE is 54 degrees. Well, again, that's the whole angle. So what I like to do is on the outside, put a big arc. If this whole thing is 54 degrees, and measure of angle ABC is 10. Well, ABC is just this tiny angle up here. That's going to be 10. Then it says find the measure of angle CBD. CBD. So I really don't need an equation here. You can use an equation if you want. Put an x in here and figure something out. But I'm just going to deal with the numbers I have. So it says here bisects. That means this angle and this one are congruent. Well, if the whole thing is 54, what I need to do first is take 54 divided by 2. Okay, that gives me 27. So I know this angle here is 27, and then, let me use a different color, this angle here is going to be 27. So now, if I want x, if I want that angle, I just need to take 27 minus 10. And that's going to be 17. So it just involves some division, some subtraction, but it is a little bit more challenging than if I just give you an angle bisector in one angle. So I have multiple angles that I have to kind of figure out. Let's do another angle bisector before we get to some triangles. And this one here says BD bisects angle ABC. Well, it's pretty easy to see in this diagram. These two are going to be congruent. Measure of angle ABC, so that's the whole angle, 17x minus 6. Okay, so the whole angle, 17x minus 6. And then it says ABD is 4x plus 6. ABD, just this one, 4x plus 6. Now again, I'm hoping it's obvious that you guys see this angle here, the 4x plus 6, is not equal to this one. So what I need to do is recognize, well, since these two are equal, and it says this one's 4x plus 6, this one down here has got to be 4x plus 6. So let's label that. And now my equation is going to be 4x plus 6 plus 4x plus 6 equals 17x minus 6. Combine your x's, combine your numbers. That's going to give me 8x plus 12 equals 17x minus 6. Now, when the variables are on both sides, I need to undo the smaller one, so I'll subtract 8x from both sides. And I kind of talked about this in class. I like to do this in one step. You certainly don't have to. My x's are going to be over here. That means I need to get this number and move it to the other side. So I'm also going to add 6 in the same step. All right, my x's cancel. 12 plus 6 is 18. 17 minus 9, or sorry, 17 minus 8 is 9, so that gives me 9x, and those cancel. Divide by 9. X equals 2. Now notice, I'm not done because it wants me to find the measure of angle DBC. So DBC is simply going to be 4x plus 6 So now I just need to do 4 times 2 plus 6, and it's going to be 8 plus 6, that's 14 degrees. Okay, let's move on to some triangles. Isosceles and equilateral. And this is really kind of a review, but it's going to be incorporated into this unit as well. In triangle ABC, AB is equal to BC. So it's an isosceles triangle. I always like to draw my isosceles triangles like this with the vertex at the top. These are the two equal sides. Notice what letters in both. B is in both, so B has to be up at the top. And then it doesn't really matter where we put A and C. And it says if AB, now notice AB is a side, right? When I give you two letters, that represents a side or a segment, is x plus 7. Let's label that, x plus 7. And BC is 2x minus 2. Find the value of x. This is really kind of a simple question. You know they're both equal, so you just set up that equation. X plus 7 equals 2x minus 2. Subtract x from both sides. At the same time, I'm going to add 2. 9 equals x. It says find the value of x, so we're done. Okay, next one, very similar, triangle ABC, AB equals BC. Same setup. B has to be at the top. There's A, there's C. AB, BC are equal. This time it says AB is 3x plus 12. And BC is x plus 18. Well, again, we're going to set them equal. That's not hard. I'll subtract x from both sides, and I'll subtract 12 from both sides, get it over to the other side. This gives me 2x equals 18 minus 12 is 6, divide by 2. X is 3. Now, the only thing that's moderately more challenging in this example, we want to find side AB. There's side AB. I just have to plug into this right here. So that's going to be 3 times 3 plus 12. It ends up being 9 plus 12, which gives me 21. Now we get to talk about an equilateral triangle. I love equilateral triangles. What do we know about an equilateral triangle? I'm hoping you guys are saying all the sides are equal. Absolutely they are. I'm also hoping you say, well, all the angles are equal. Absolutely they are. And you know what each one of those is. Because remember, the 3 angles of all triangles add up to 180. Well, since they're all equal, what we want to do is take 180 divided by 3, that's 60. So in an equilateral triangle, the 3 angles are all 60 degrees every single time. So now it says, well, if the measure of angle A is 7x minus 24, find the value of x. Well, I just need to do 7x minus 24 equals 60 because I know every one of those angles is 60. Add 24 to both sides. I get 7x equals 84, divide by 7, and x is 12. All right, last problem. This one's challenging. So in this example, it says triangle ABC is equilateral. A, B, C is equilateral. So all 3 of these sides are equal, all 3 of these angles are equal, and they're all 60 degrees. I'm going to write that in first, okay? So this angle up here is 60 degrees, this angle down here is 60 degrees, and this whole angle is 60 degrees. I don't know what the individual pieces are, but I know the whole thing is 60. Got it. So now what? Triangle BCD is isosceles with BC equal to CD. BC equals CD. So if this triangle is isosceles, guess what? These 2 angles now are equal. I don't know what they are yet, but I know those 2 are going to be equal. So I'm going to mark it. This angle here is equal to this angle here. Now, last piece of information. BD bisects angle ABC. So here's ABC. And what they're saying is this bisects it. So that cuts it in half. Now, I know it doesn't look like it, but remember, you can't go by scale because none of these figures are drawn to scale. But these 2 angles are going to be congruent here. means this angle here is congruent to that angle there. And because we know the total is 60, you divide that by 2, and I get 30 degrees here, and I get 30 degrees here. Now remember, let's work our way around the figures, kind of like that puzzle problem we did in day 2. Notice, these two angles are also equal. So if this one here is 30, that one there's got to be 30. All right, well, let's keep working our way around the figure. Notice now, here's a triangle. This angle's 30, that angle's 30, so this whole angle here is going to be 180 minus 30 minus 30, or 180 minus 60. So that whole angle is 120. Well, if this whole angle here is 120 and that piece there is 60, then this piece here's got to be 60. All right, so let's fill that in. Now, I might need to find some other angles, but at this point, I've found quite a few. Let's see if I can answer all of these questions. I haven't even looked at those yet. I just kind of worked my way around this puzzle. So the first one is DBC. DBC. Yep, I did find that one. That was 30. Let's fill that in. Next, we have CDB. CDB. Yep, I found that one. That one's also 30. And then the last one, BCD. BCD. Yep. Remember, that's the whole angle there. That was the 120. So I've got everything I need. Don't need to find anything else. All right, guys, that's it for day 3 notes. Now you have all the information you need to do Delta Math homework 2.3. Thanks for watching.